Okay, so now we're going to move on to chapter 13, and we're going to get into some trigonometry. Section 1 is how to use trigonometry in right triangles. Some of this you may have seen in geometry a little bit, so hopefully it's a little bit of a review, but then there's some new information. In general, here's our right triangle. Square there means it's a right triangle. We have our hypotenuse that's opposite the right angle. This little variable indicates what the reference angle is. The reference angle is the angle that we're concerned about. This is the Greek letter theta. It's typically used in trigonometry. So if this is our reference angle, this is our opposite leg because it's opposite of the reference angle. This is our adjacent leg because it's right next to the reference angle. So the trig ratios we're worried about, you've probably heard of sine, cosine, and tangent before. Sine is the ratio of the opposite leg over the hypotenuse. Cosine is adjacent over hypotenuse. We'll just shorten it up there. Tangent is opposite over adjacent. Okay. The new ones here that you may not have seen before, this is shortened for cosecant. It's just C-O and then secant, cosecant. Cosecant is the reciprocal of sine. So it's hypotenuse over opposite. The next one is secant, which is the reciprocal of cosine. It's hypotenuse over adjacent. And COT is cotangent, and that's the reciprocal of tangent. Adjacent over opposite. So these are the 6 possible trig ratios within a right triangle. So let's do an example here. Number 1, evaluate the 6 trig functions for theta. So here's my reference angle. It's important to know what the reference angle is, and I can evaluate all 6 of these. Okay. Now the first thing I have to look at is I know 2 sides, but I don't know the third. I don't know the hypotenuse. Okay, so how do I find the missing side? Well, I use the Pythagorean theorem. Okay, so in this case, the hypotenuse squared is equal to the sum of the 2 legs squared. So we're going to have 4 plus 36. So hypotenuse is going to be the square root of 40. Now I should simplify that down, because that's going to be the square root of 4, square root of 10, which is 2 square root of 10. So we have to leave it in our simplest form here. So I'm going to put 2 square root of 10 there, now that I found that. Now I can write all 6 of these. Okay, so let's start with sine. Sine is opposite over hypotenuse, so it's going to be 2 over 2 square root of 10. Okay, now what don't we like about this? We don't like square roots in the denominator, so I need to rationalize. So I just multiply top and bottom by the square root of 10. So then I'm going to have 2 square root of 10 over, this is going to give me 10 times 2 is 20, which is equal to the square root of 10 over 10, because 2 over 20 is 1 over 10. Okay, so that's how I'll do that one. So I have to simplify things down, so I got to use some of my old information. I didn't set this up very well. I didn't leave myself a lot of room. Cosine theta. Cosine is adjacent over hypotenuse, so it's going to be 6 over 2 square root of 10. Maybe I'll simplify this part down first, so it's going to be 3 over 1 square root of 10. I'm going to zoom in just a little bit and then I can rationalize by multiplying top and bottom by the square root of 10. So I end up with 3 square root of 10 over 10. So that's cosine, tangent. Tangent is opposite over adjacent, so 2 over 6, which is 1/3. Okay, so those are the first three. Then I need to do cosecant, secant, and cotangent. Cosecant of theta. Cosecant is the reciprocal sine, so sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So it's 2 square root of 10 over 2. And the 2's will cancel, so it's just the square root of 10. Secant. Oops. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. 2 square root of 10 over 6, which is the square root of 10 over 3. And then finally, cotangent of theta. Cotangent is adjacent over opposite, so it's 6 over 2, which is 3. So I've written out all 6 of the trig ratios for this triangle. And we have to leave it in square root form and simplify things down as we go. Okay? Let's look at the next one here. In a right triangle, if cosine of theta is 7 over 10, what is sine of theta? Okay, so if I get a problem like this, the first thing I'm going to do is draw a triangle. Okay, I'm going to let one of the angles be theta. If cosine of theta is 7 over 10, cosine is adjacent over hypotenuse. Okay, so this is my adjacent leg, and this is my hypotenuse. Okay, so if I want to know what sine of theta is, I need to know what the opposite leg is. So again, Pythagorean theorem here. We'll go 10 squared equals, we'll call this x squared plus 7 squared. So we have 100 x squared plus 49. Subtract 49, I'm going to get 51 equals x squared. So x equals the square root of 51. I don't think we can simplify that down. So therefore our sine of theta, this is the square root of 51. Sine would be opposite over hypotenuse, so the square root of 51 over 10. And we'd leave it like that. Okay, so take what's given, label a triangle, find the missing part, and then find the other ratio. Okay, special right triangles. Page 853. Let me pull my book over here. Okay, so we have 2 special right triangles. We got the 30-60-90 triangle and the 45-45-90 triangle. So what we have drawn here is the simplest of each. Okay, but what you need to remember is the side opposite the 30-degree angle is the short leg, and then the side opposite the 60 is the long leg, and then you've got the hypotenuse. For a 30-60-90 triangle, if the short leg is 1, the long leg is the square root of 3, the hypotenuse is 2. Okay? Because there's a relationship here, and I've got it written. Go back to my paper. Got it written here. In general, whatever the short leg is, you multiply that by the square root of 3 to get the long leg. And the hypotenuse is twice as long as the short leg. That's how that one relates. 45-45-90 is an isosceles triangle, which means the 2 legs are the same, and the hypotenuse is whatever the leg is times the square root of 2. Okay, so in this chart, it shows us all the different ratios of the simplest of each of these triangles. So for example, if I want to know what the sine of 30 degrees is, the sine of 30 degrees is 1 over 2. The cosine of 30 degrees is the square root of 3 over 2, adjacent over hypotenuse. Tangent of 30 degrees is opposite over adjacent, 1 over the square root of 3. But then when you rationalize, we get 1 over square root of 3. When I rationalize, I get the square root of 3 over 3. That's where this one comes in here. Okay, so you can find all the different ratios of these triangles here. And before long, you'll have these almost memorized, and you'll be able to recreate this this table here. Okay, so we're going to use that information to solve for missing parts of triangles. So for example, let's say I've got this triangle here. I've got a 30-degree angle. I've got the hypotenuse. Okay, so I have to use this general rule, and I know that the hypotenuse is twice as long as the short leg. So if 8 is the hypotenuse, what's the short leg going to be? It's going to be half, right? So y is going to be 4. And then to solve for x, then I find my long leg by multiplying by the square root of 3. So this is 4, so this is 4 times the square root of 3. That's how I'd find those. Okay, now for this one, this is a little trickier. I know that these are the same, so x and y are both going to be the same. In order to figure out the hypotenuse, I would multiply by the square root of 2 to get the hypotenuse. If I know the hypotenuse, I want to go backwards, I divide by the square root of 2. So this is going to be 10 over the square root of 2, which we can rationalize and get 10 square root of 2 over 2, which is 5 times the square root of 2. And y is the same thing because they're the same. Isosceles triangles. Oops. So that's what that one's going to look like. Okay. Unfortunately, we don't always have these special triangles, 30, 60, 90, and 45, 45, 90. Sometimes we have angles that we can't just apply these rules to. In that case, a little bit. Sorry. Solving a triangle means find all the unknown parts. Okay, the first one's going to be a special triangle, but the other two are not. So the first thing you're going to do, and the way the book has this is they have this triangle set up. Angle A is always opposite side A. Angle B is opposite side B. Angle C is opposite side C. Angle C is our right angle there. Okay, so if I was to draw this triangle out, I call this A, B, C. This is A, B, C. Angle B is 60 degrees. Side A is 7. We need to find everything else. Well, the first thing I know that I can find is angle A. One property on triangles is the sum of the angles is 180 degrees. So 90 plus 60 is 150, so angle A has to be 30 degrees. So we have a 30, 60, 90 triangle, special one. Okay, this is my short leg, so that means side B is the short leg times the square root of 3. So that's easy. And then side C is twice the length of the short leg, so it's going to be 14. So I've solved for all the missing parts in that triangle. I'm done. Okay, next one. Draw this triangle. I don't know why I'm drawing it in the opposite direction, but it doesn't really matter. Little a, little b, little c. Okay, so angle A is 32 degrees and side B is 10. We need to find everything else. So the first thing I can find is angle B, because again they have to add up to 180. So angle B is going to be 180 minus 90 minus 32. So that's going to be 58 degrees for angle B. Okay. Now this is where we're going to get into some trigonometry. We need to find the rest of the parts. So angle B is 58 degrees. I can't use the Pythagorean theorem because I only have one side out of the three. So I need to use a trig ratio. So if I'm going to use angle A as my reference angle, side B, and I want to find the hypotenuse, which trig ratio do I use? I have this leg, I have the leg next to it, so I have the adjacent and the hypotenuse. So then I'd have to use cosine. So I'd set it up like this. Cosine of 32 is equal to adjacent over hypotenuse. I need to solve for C here. Okay. So if I multiply both sides by C, the C's will cancel. And then I can divide by the cosine of 32, because now I have C times the cosine of 32 equals 10. Divide both sides by the cosine of 32, and I'm going to have 10 over the cosine of 32. And now I don't know what the cosine of 32 is, so I have to go to my calculator. One thing you want to make sure is you hit your mode button, you want to make sure you are in degree mode. This calculator, the default is radian mode, and we'll talk about radian mode later in the chapter. But we need to be in degree mode. Okay, so now if I do this calculation, I just go 10 divided by, there's the cosine button, and I get 11.8. So I've got side C. Okay, and now I can find, I found side C, I can find side A now. I could use Pythagorean theorem now, but I'm just going to use another trig ratio just to get used to it. So if I use this one, and this one, I could use tangent. Tangent of 32 equals opposite over adjacent. So this one's easier because I can multiply both sides by 10. Those will cancel. So A is going to equal 10 times the tangent of 32. So 10 times tangent 32. Enter 6.25. And that's that one. Okay, so I've got one more there. I'd like you to try that one and bring it to class. I'm running out of time. So give that one a try. See if you can use your calculator to calculate all the missing parts.